Hello, we're going to go ahead and go over some more examples for Circles Day 2 lesson. And this first example says, find the center and the radius of a circle, then sketch the graph. And we can tell already that our circle is not in standard form, which we know that means that we have to complete the square in order to write this equation in standard form. So the first thing I look for is I make sure all of my x's and y's are on the left-hand side, and then I have to make all of the constants on the opposite side. And I can see that, I have a constant that is not supposed to be there. So my first step is to eliminate that constant by moving it to the right-hand side. So then I have x squared plus 6x. I'm going to leave a space for that constant. Y squared minus 4y. I'm going to leave another space, and that will equal -4. So now what I have to do is complete the square for my x terms, complete the square for my y terms, and then I will be able to write it so it looks like a circle. So I identify b. B is +6. So when I complete the square, I take b, I divide it by 2, and then I square it. So 6 divided by 2 squared will get me 3 squared, which is 9. So remember, this is what I use when I factor, and this is what I use to add in order to complete the square. So I'm going to go ahead and add 9 to both sides. And then what I'll actually do, and this is a little different than we did last time in our last video, is I'm going to go ahead and write it as a perfect square right now. And then I know x's are good to go, they are done. So I can rewrite this expression as a perfect square. So that will be x plus 3 squared. All right, and then once I do my y's, I will do the same thing down here. So let's go ahead and identify b. B is -4. So I take b, I divide it by 2, and then I square it. So that will be -4 divided by 2 squared, which will be -2 squared, which is 4. All right, so remember, this is what I use to factor, and this is what I will add to complete the square. So I add 4 here, add 4 here, and now I can write my y trinomial as a perfect square. So it's y -2 squared, and then I can add all of these together to get that right-hand side. So -4 plus 9 plus 4 is going to equal 9. And then I can also now, once I have my equation in standard form, I can identify h and k. So if I look at my standard form of the equation, I can see what h and k are. So since I see a positive here, I know that h has to be -3. I have a negative here, so k is +2, and then r squared will give me my radius once I take the square root. So the center is -3, 2, and the radius will be 3. So now I have enough information to graph, so I can go ahead and go back here, -3, 2, and my radius is 3. So I plot -3, 2, and then I'm going to go 3 units out in either direction. So that would be 3 units, up 3, left 3, and down 3. And then I will go ahead and draw my circle. All right, so I have completed the square. I have identified my center and my radius. So this question is complete. All right, I have one more of the same type of question, and then we'll look at a few more proof examples. And this is another example where the terms are all in the wrong place. So I'm going to go ahead and move them to the proper side. And in this time, I'm going to do it in just a couple steps. So again, depending on how comfortable you are with your algebra, you can take it one step at a time, but do what you need to in order to get to the right answer. So we're going to go ahead and move my x's first. So I have x squared minus 2x plus 13. I kind of like to order them right away. And then my left-hand side, I'm sorry. My right-hand side, I'm left with my 2y terms. So now I have to just move these to the other side. So I'm going to do that at the same time. I'm going to subtract 8y, then I'm going to add y squared. So subtract 8y, add y squared. And so now I have nothing left on my right-hand side. So I'll go ahead and write down everything I have on my left-hand side. So x squared minus 2x plus y squared minus 8y plus 13 equals 0. So you can see that all I have to do now is get rid of this constant. I need to move this, and then I will be ready to start completing the square. So I have x squared minus 2x. I'm going to leave my placeholder, plus y squared minus 8y, leave a placeholder, equals negative 13. All right, so now I can go ahead and complete the square. So here, b is negative 2. So when I complete the square, I take b, I divide it by 2, and I square it. So negative 2 divided by 2 squared will get negative 1 squared, which is positive 1. So I'm going to add positive 1 to both sides of my equation, and negative 1 is what I'm going to use when I factor. So I'm going to go ahead and add 1 right now to complete the square. And I'm going to factor my x's right away. So x minus 1 squared, and now I can go ahead and move on to my y's. So again, I identify b, the coefficient in front of my y term. B is negative 8. So I take b, I divide it by 2, and I square it. So it's negative 8 divided by 2 squared is equal to negative 4 squared, which equals 16. So I use negative 4 when I factor, and then I add 16 to both sides. So add 16, and now I can factor to write this as a perfect square. So plus y minus 4 squared. And now I have to just evaluate my right-hand side. So this equals negative 13 plus 1 plus 16 will equal 4. All right, so in order to graph, I have my standard form of my circle equation. Now I have to identify h and k, so I can use that standard form to help me. And now I can see that h will be 1, k will be 4, and r will be 2. I'll take the square root of both sides, and r is 2. So the center of my circle is hk, which is 1, 4, and my radius is 2. So again, that is what I need in order to graph. So I can go ahead and take that back up to my coordinate plane. The center is 1, 4, radius is 2, so 1, 4, and then I'll go out 2 units in every direction. So 2 units here, 2 units up, 2 units left, and 2 units down. All right, so that will be my answer. 1, 4 is my center, my radius is 2, and here is my graph. I have 2 more examples for you. This is the example, or they are the examples of proving or disproving whether a point lies on a line. So I'm given point square root of 18, comma, negative 4, and I'm trying to see, is this on the circle that's centered at the origin that contains the point 6, comma, 0? So remember, if it's centered at the origin, I know that h and k are both going to be 0. And then I can tell my radius is going to actually be 6 units. And remember, I know that because I have my center at 0, 0, and then I go out 6 units to get to this point 6, 0. So remember that radius is how far away every point is from the center. So I can tell that R, or my radius, will be 6 units. So R equals 6. So before I can tell if my point is on the circle, I have to write the equation of this circle. So I'll write this in standard form, and then I will substitute in H, K, and R. So I will plug those in. So that will get x squared plus y squared equals 36. And then I'm going to use my point and substitute that in for x and y to see if I get a true statement. So my point is root 18, comma, -4. So I'll substitute in the square root of 18 for x, and then I'll substitute in -4 for y. So the square root of 18 squared plus -4 squared, and I'm trying to determine, does this equal 36? So the square root of 18, remember those cancel out, my square root and my square. So I'm left with just 18. And then -4 squared, remember that's -4 times -4, which gets 16. And if I add these together, I see, oh no, I was close, but I didn't quite equal 36. So it's close to the circle, but no, it is not on the circle. So no, the square root of 18, comma 4, -4 is not on the circle. All right, we'll try one more of those. So again, we're proving or disproving whether the given point is on our circle described here. So I have the point 4, comma, -3. My circle again is centered at the origin. So that will be 0, 0. H and K will both equal 0. And then I know my ordered pair is going to help me identify what the radius is. So if my origin is 0, 0, if I go up to 0, 5, I know that radius is going to be 5 units. So R will equal 5. Let's go ahead and write our equation in standard form. So x minus h squared plus y minus k squared will equal 5 squared. Substitute in h, k, and r. And I will get the equation x squared plus y squared equals 25. And now I have to just decide or determine if this point lies on the circle. So I'm going to substitute in this point to see if it's going to be a solution on this circle. So I will substitute in 4 for x, and I will substitute in -3 for y, and I'm trying to see, does that equal 25? So 4 squared will be 16. -3 squared, remember, is -3 times -3, so that's +9. And does that equal 25? And in this case, yes, we can see that does equal 25. So our point does lie on the circle. So we say yes, 4, -3 is on the circle. All right, that is the end of our extra examples. Please feel free to reach out if you have any questions. Otherwise, after you complete the practice, there will be a check-in on Google Classroom. So go ahead and complete that like it's an actual assessment, and then it will help you determine how ready you are for our assessment next week. Let us know if you have any questions, and we'll see you next time. Thank you.